Hey folks, in this video we're going to look at polarized light by looking at glare that occurs from a reflection off of a non-metallic surface. So here we have a painting of Albert Einstein on the wall. If I tilt my camera down so I'm looking at my conference table, you can see clearly there's a reflection of that painting coming off the conference table. It's not a total reflection like we'd expect from a mirror, but it is a reflection due to the light striking the top of the table and being reflected, so we can certainly see that image. Now, when we have a reflection off of a non-metallic surface like this, the light is preferentially polarized in a direction that's parallel to the surface. In this case, it's horizontal. So if I take my finger, so I'm just going to represent that, the light that is reflected off of that surface to my camera is polarized in this direction, meaning that the electric field associated with electromagnetic radiation is oscillating in the horizontal direction. That's the polarization. So it's polarized in the horizontal direction preferentially. Now, polarized sunglasses, not regular sunglasses, but polarized sunglasses are designed to reduce glare, and that reflection is what we would call glare. They're designed to reduce glare by absorbing light that is polarized in that horizontal direction. It transmits vertically polarized light, so light that's polarized like this, and all the light that is striking the table is polarized in all directions. It's just the reflection is polarized in that horizontal direction like that. All right, so the light that is coming off horizontally is going to be rejected by the filter, by the lens of the sunglasses, but it's going to allow vertically polarized light. So when I look at this, I'm going to bring my sunglasses really close here to the camera lens, see if I can do this. So we pretty much block all of it. Okay, there we go. You can see that when you're looking through the sunglasses, that reflection is essentially gone. All right. So just to prove, however, that it is the reason it's polarized in a horizontal direction, it's gone, I'm going to bring my sunglasses back here to cover the lens. And now you can see, wow, my sunglasses are in front of my camera lens, but because I rotate it, let me show you what I did. We started out rotating it, having it in this direction, all right, normally how we would wear it, and you see that it has rejected the glare. We're not seeing the reflection. But if I rotate it 90 degrees, now when I rotate it 90 degrees, what has happened is that when it's in the normal position, it's rejecting horizontally polarized light like that, okay? But if I rotate it 90 degrees, it's going to be rejecting vertically polarized light like that. So again, horizontally polarized light, we're not seeing it. But when I rotate it 90 degrees, now it's transmitting horizontally polarized light, but rejecting the vertically polarized light. And you can see there's the reflection, all right? The reflection is there. So the act of rotating at 90 degrees allowed that horizontally polarized light to transmit. So polarized sunglasses will do this, and you can look at glare. You can, if you have a pair of polarized sunglasses, find a reflection off a non-metallic surface. They're everywhere. You can see it. And just take your sunglasses and rotate the sunglasses 90 degrees and see what happens. When it's in its normal position, it's going to reject that glare. It's not going to transmit the glare, but when you rotate it 90 degrees, it will reject that. So that's polarization. That is how we can look at polarized light, how glare is actually an example of light that is preferentially polarized, generally in the horizontal direction, and how polarized sunglasses will reject that glare. That's the point. You get glare if you're driving your car, for example, and you see glare off of the glass windshield of another automobile or something like that. If you're wearing polarized sunglasses, that's going to help to reduce that glare factor. So anyway, hope that is understandable. If you have any questions, let me know.